we've got a new chapter. We call it Chapter 4, Unit 4, which is on factoring. It's going to take a lot of the ideas that we had before and take them a little bit further. So remember, last unit we dealt with functions. And here's an example of a function that would model gravity. It would be a ball starting at 60 feet high in the air, falling 16 feet per second squared, and thrown upwards 24 feet per second to start. And that ball would, its flight path would look kind of like this. And finding this route is important, but difficult, because we would set our equation equal to 0, and that's a tough equation to solve. Because there's this b term here, we can't just solve it with our normal algebra 1 type methods where we isolate x, because there's two x's. Having two x's makes this quite difficult to solve. So we're going to start working on some new ways to solve types of problems. The first one we're going to work towards is factoring. So we're going to start factoring today. We won't solve problems like this today, but that's our goal for this chapter, at least one of our goals. So I want to make a clarity between the acts of simplifying and factoring. Simplifying is when you combine like terms and follow the order of operations in order to write an expression as simply as possible, where there's no parentheses, there's no like terms to combine. Remember that like terms have the exact same powers on the exact same variables. If you have like terms, you can add up the coefficients. So 3x squared plus 2x squared is 5x squared, and negative 6xy to the third plus 1xy to the third would become negative 5xy to the third, because I'm adding negative 6 plus 1 to get negative 5. So like terms have the exact same variable and the exact same power. Unlike terms cannot be added. Okay, so 2x to the third plus 2x to the fourth, that can't combine any further. That's as simple as I can make that. And negative 6xy squared plus 2x squared y, those are not like terms. They don't have the exact same variable power combinations, so I can't add them together. I also can't subtract them. I can multiply whatever I want. Like I can take this, and even though they're not like terms, I can multiply them to get 6x to the third. There's 2x's here and there's 1x here, so altogether there's 3x's. I can multiply unlike terms, but I can't add or subtract them. So when you're simplifying, you take your like terms, you combine them. For this first example here, I'm going to distribute this negative to all of these things. So I get 3x squared plus 5x minus 8 minus 2x squared plus 6x plus 1. Then I combine my like terms. So 3x squared minus 2x squared is just 1x squared. 5x plus 6x is 11x. And negative 8 plus 1 is negative 7. This is simplified. It's also written in what's called standard form. Standard form means that the powers are decreasing, x to the second, x to the first, and then no x's. So if you're in standard form, your powers come in a decreasing order. Biggest power first and getting smaller from there. Okay, here's another one for me to simplify. This is going to involve distribution. I distributed last time also. I distributed the negative 1 that was here. Here I'm going to distribute 4x squared. So every single term gets multiplied by 4x squared. 4x squared times 2x to the third is 8x to the fifth. That was my first one, 4x squared times 2x to the third. Next I do 4x squared times 3x squared. That becomes 12x to the fourth. So the powers add. X squared times x squared is x to the fourth. So 4x squared times 12x is going to become 48x to the third. And 4x squared times negative 8 is going to be negative 32x squared. This is in standard form. The powers are decreasing. And I have simplified. The parentheses are gone, like terms are all combined. Let's do one more practice of simplifying, and then we'll start talking about factoring. I'm going to distribute this negative 2xy squared to everything. We haven't done one with x's and y's yet, so I'm going to break this down into little pieces. I'll zoom in too. I'm doing negative 2xy squared, and I'm first going to multiply that by this 3xy right here. I'm also going to do negative 2xy squared times this 4x. I'm also going to do negative 2xy squared times this negative 5y. I don't like how that times and minus right next to each other, so I'm going to put that in parentheses. And I'll do negative 2xy squared times negative 6. Okay, I'm going to do this one first. 2xy squared times 3xy. Well, I'm going to multiply each individual piece. So I'll switch colors to try and be less confusing. Negative 2 times 3 is going to be negative 6. 1x times 1x is x squared. And y squared times y is y to the third. So there's my first piece. I'm going to do these two. Well, negative 2 times 4 is negative 8. X times x is x squared. Y squared just stays y squared. Let me do these two. Negative 2xy squared times negative 5y. Well, negative 2 times negative 5 is positive 10. This gives me a positive 10. X is just by itself. And then y squared times y is y to the third. Finally, negative 2 times negative 6 is positive 12. And then there's just xy squared because there's no variables to multiply those by. So I put this all together, and I'm going to get negative 6 x squared y to the third minus 8x squared y squared plus 10x y to the third plus 12xy squared. Okay, that's it simplified. So that's the first time we've multiplied with two variables in a problem like this. Combine the x's, combine the y's, combine the coefficients. And coefficient is a word that means the number in front of the variable. So negative 5, positive 4, positive 3, negative 2. Those are all coefficients. For the record, this number right here, negative 6, is called a constant. A constant is a number without a variable attached to it. Okay, factoring is we take the simplifying process and do it backwards. You identify what each term has in common, and then you pull it out. It's called factoring out the greatest common factor, which greatest common factor we usually abbreviate as GCF. Okay, so I'm going to look at each of these expressions and identify what is the biggest thing that every single term has in common. For example here, 4, 4x squared, 6x, and negative 8. Each of those things has a 2 that I can pull out of it. Each of these things can be divided by 2. I can divide by 2 and still get whole numbers. But I don't divide by 2. I don't actually do the division. I do what's called factoring. So I pull the 2 out in front. Each term can be divided by 2, but instead of dividing by 2, I pull out a 2 in front. And now it's like, if I wanted to redistribute to check, I could. If I redistribute, I'd get 4x squared plus 6x minus 8. But I factored out the 2. 2 was the greatest common factor, so I pulled it out of everything. Okay, this might seem like a bit much, but stay with me. We'll do several examples. I look at each of these terms, and I ask, what is a number that can divide all of them? Every single number can be divided by 3. So I'm going to divide them by 3, but I can't actually just do the division. I have to factor it. I'm going to pull a 3 out. So I'm going to pull a 3 out, and then what happens is each of these terms I divide by 3. So 3x to the third divided by 3 is just x to the third. 9x squared divided by 3 is 3x squared. 12x divided by 3 is 4x. Negative 15 divided by 3 is negative 5. This is the factored form of the expression. Okay, so we can simplify, but we can also factor. And it's like you undo one with the other. Like, if I were to simplify this expression, I would redistribute the 3. And I would get, again, 3x to the third plus 9x squared plus 12x minus 15. So this version here we call the simplified form. Sometimes it's called the expanded form. Whereas this version here we call the factored form. They both have value. So sometimes you'll end in the factored form. Sometimes you'll end in the simplified form, and it actually just will tell you in advance, factor or simplify. So you can check if your factoring is correct by going back and re-simplifying. If you simplify and you get what you started with, notice how this and this are the same. If you simplify and you got what you started with, that means you factored correctly. Or at least it means you didn't factor incorrectly. Okay, what do these have in common? Well, both 6 and 8 can be divided by 2. But also, each of them has an x squared at least. Each of them has at least 2 x's. So since each term has at least 2 x's, I'm going to pull out a 2x squared. That leaves me with 3x squared plus 4. Okay, so what I just did is I took each of these terms and I divided them by 2x squared. That got me this and this. And since I divided both things by 2x squared, the 2x squared comes out in front. Okay, 2 more examples. Maybe pause and see if you can identify what I'm going to pull out first. Each term can be divided by 6. And each term has at least an x squared in it. So this leaves me with 2x squared plus 3x minus 4. The way that I would check is I would redistribute, and I would get 12x to the 4th plus 18x to the 3rd minus 24x squared, and those two things match, which means that my factoring was correct. My factoring checks. Okay, last one of these. 5, 10, and 16 actually don't have any number they all have in common. There's no common factor I can pull out of 5, 10, and 16. There is, however, a bunch of y's. I can pull a y out of everything. I can pull a y to the 4th out of each of these things. That leaves me with 5y to the 4th minus 5y squared, minus 10y squared plus 16y. There's my factoring. Okay, last set here. Every expression has what's called a leading coefficient. Okay, a leading coefficient is the coefficient on the term with the highest power. So here, the leading coefficient is 4. Here, it's 3. Here, it's -1. And here, it's +1. Every expression has a leading coefficient, and that means the coefficient on the highest power. It doesn't necessarily mean the coefficient in front. If you're not written in standard form, like if I had this, the leading coefficient would be 5. Because that's the coefficient on the highest power. 3 is the highest power. So it's first best to write things in standard form and then find the leading coefficient, the number in front. Okay, if you're factoring and your expression has a negative leading coefficient, if your leading coefficient is negative, like it was here, factor it out. So I'm going to pull a -2 out of these. And all the signs switch. This got divided by -2, this got divided by -2, and this got divided by -2. I'm going to pull a -3, -3x actually out of this. And I get 6x to the 3rd minus 4x minus 6. And here I'm just going to pull out a -y to the 4th, giving me y to the 6th minus y squared plus 1. I went through those last 3 a bit too quickly. We'll talk about them in class, and maybe I'll start the next video with those as well. But there's factoring out greatest common factors. Now, factoring is what you do when you identify what everything has in common, and then you pull it out. When you pull out everything that's in common, what's left is what's different. Okay, the things that remain are different. This is actually a very important problem-solving strategy. It's how you play detective. And not just in math, but solving all kinds of problems. If you can identify what things have in common and remove that, what you're left with are the things that are different. And you can analyze those and look for patterns, look for differences, or look for issues. So factoring is a super useful and practical skill that you probably use all the time and don't think about. But that'll be enough for us for today. I'll see you next time.